A very good evening to Doctor and the members on the floor. Today we would like to present our project entitled Garage Door Mechanism Project. So let's come to our introduction. A machine is a device used to convert, transmit and direct forces or energy to complete a certain task. And the mechanism is known as linkage, made of several links connected by joints, commonly does not involve power source. With the presence of links and joints, degrees of freedom DOF is used to categorize mechanisms based on the complexity of the motion generated based on Grobler's equation. And in our project, garage door will be explored and discussed, and each mechanism will be studied, such as DOF, velocity analysis, and force analysis will be taken into consideration. Moving next will be the basic garage door mechanisms. The first one is a side hinge, and the following characteristics are stated here. And this is the image shown. The second is a canopy door with the following characteristics as well as the image shown beside here. And the third one will be the retractable door, given with the following characteristics as well as the image shown right here. So these are the basic mechanisms of the garage door that we have found.
Moving on to the selection process, according to the basic description, we have selected the canopy garage door as our type of garage door design due to its simple design, availability in all material, low cost, less garage space consumed, and also less clearance for door trajectory. Let's move on to the next point, which is the available design in the market. So there are 3 available designs. The first one has 4 links and 4 joints, and it has a total of 1 degree of freedom. This design has low cost in manufacturing and maintenance. Second design, as shown here in the diagram, has 2 pin joint, 1 slided joint, and also 1 link. This design is low cost in manufacturing and a higher cost in maintenance. It is also more prone to damages due to its fairly simple design. For the third design, it has 5 links and 5 joints. This indicates that it is more complex than the first 2 designs. This complexity contributes to higher cost in manufacturing and maintenance, and also leads to higher chance in failure.
Moving on, among the 3 designs shown, the first design was chosen to be the best design, as it is simple to operate, low manufacturing costs with great functionality, low garage space consumed, as well as no sliding parts, causing lower maintenance. This is the new design kinematic diagrams. By using the graphical method and the linkage software, we have determined the design as shown based on the first design. This is the initial position of the link and the final position of the link. This is the video for the full cycle. Moving on, based on the first design, we modified it by adding an actuator to the mechanism. Hence, it will be operated automatically, which is more convenient for the user compared to operating it manually. It also saves space as no springs are used. The joint B and M are situated at the walls of the garage, and it has an offset of 5 cm to avoid interference between the links. The height of the door was chosen to be 210 cm, considering the average car width is 190 centimeters, which chose to have the door width to be 270 centimeters, so that it is wide enough to have space for the car to enter, as well as when the car door is open. The gap between the frame is 1.125 centimeters. It is found by tracing the movements of the door relative to the complex triangle link. It is found that the clearance needed between the door and the top of the door frame is around 0.6 centimeters. Thus, we added an extra clearance, making it 1.125 centimeters. Now, for the linkages, the width and thickness are chosen to be 2.4 centimeters and 2.0 centimeters respectively to withstand the weight of the garage door. As you can see, this is the assembled CAD design of the mechanism. We use 2 of the mechanism on each side, as shown in the figure. This design features that is simple, attached to the side wall, making it less space consumed. The material chosen is an aluminium, making it strong, lightweight, and highly resistant to corrosion. It is also automatic, making it convenient for users.
Moving on to the velocity analysis, the garage door is automated by an actuator located at joint B, which rotates 103 degrees from initial to the final position, and assuming it takes 10 seconds to fully open or close the door, the angular velocity of the mechanism is 0.18 radians per second, which is 1.72 rpm. Hence, the velocity of the garage door is taken at point C as it is attached to the mechanism, and the velocity calculated is 12.74 cm per second. As for the force analysis, the mechanism is sectioned into 3 sections to determine the static forces in each section. Figure 1 shows the free body diagram of the full mechanism and the forces in equilibrium. The weight calculated acting downwards from the mechanism is 901.048 newtons. Meanwhile, the vertical and horizontal force acting on joint M is 957.3 newton upwards and 86.62 newtons to the right respectively. Lastly, the vertical and horizontal force acting on joint B is 56.25 newton downwards and 86.62 newtons to the left respectively. To conclude, the design of our mechanism prioritizes the safety, space savings, and the functionality. The design as well as the relevant analysis of the final product have been created and calculated to ensure that it can fulfill all the required factors. So that is all from us. Thank you.